Alright, in this section, we're going to talk about the definitions of the trig functions for any angle. So prior to now, we've really focused on just the unit circle, unit circle, unit circle, and you've learned all your trig definitions in respect to the unit circle with a radius of 1. So now I'm going to say, if I give you any radius, how does that apply? And so basically now we define sine of theta as the y value over r. Well, you remember we would say the sine of theta is just y for the unit circle, because what's the radius of a unit circle? 1, so y over 1 was just y. So it's not that we're changing anything, it's just now we're going to say, oh, well, the radius might not be 1, so let's define all of our trig functions if a radius possibly something else. So cosine of theta is x over your radius. Tangent is going to be your y value over your x value, which that didn't change at all. Okay, cosecant, same idea. What about if I use the reciprocal? What would I get? R over y. Okay. What about for secant theta? Good, r over x, and cotangent, x over y. And basically this is just some pictures to say, well, this angle theta is in quadrant 1, this angle theta is in quadrant 2, quadrant 3, quadrant 4. So it just shows you the different locations of a particular point. Now, let's see an example. Right here, this first example, when we have the ordered pair -3, -5, find all 6 trig functions of theta. So first, let's just sketch where this point would be so we have an idea of what quadrant it would fall in. If I had an x value of -3, if I started at the origin and I went an x value of -3, and then I went down -5, I'd be somewhere here in quadrant 3. So let me just draw a sketch. I'll say, well, I know I'm somewhere here in quadrant 3. I went x value is -3. The y value was -5, so this is my point P. -3, -5. Okay, what's my missing side? I don't know the radius side, so how could I find the radius side? If I know 2 sides of a triangle and miss the third, Pythagorean theorem, right? So take a minute. Okay, while you're doing Pythagorean theorem, we also have the definition from above. The radius is equal to the square root of x squared plus y squared. Okay, this is an alternate way, although many of you prefer Pythagorean theorem and you'll get the same answer. So I'm just going to show you this just so you have an idea of an alternate way. So x is going to be -3 squared, which is just +9. The y value is -5 squared, which is +25. So the radius is equal to the square root of 34. Again. Okay, so this was the same value you would get if you use Pythagorean theorem. That's why most people do that. But let me just remind you, here's the definition using the radius, me using the definition. Okay, a lot of times it's okay to use the Pythagorean theorem as well. So anyway, we find our missing side over here to be square root of 34. So we had to calculate that one on our own. Now we want to evaluate our trig functions. Okay, so I just paused it. I jotted down my definitions from the previous screen. Now let's fill those in. So if this is angle theta, here's angle theta. What is the y value? -5 over the radius, which is the square root of 34. So this is just going to be -5 over the square root of 34. Now we want to rationalize that. So go off to the side and do the scratch work, which you would just multiply by the square root of 34, square root of 34, which would leave you with -5 square root of 34 over 34. It's kind of squished there. Okay, so what about cosine? It's your x over your r. So the cosine is going to be -3 over your radius, which once we rationalize, that's going to be -3 over the square root of 34. And when we rationalize this, the simplified form will be this. Okay, tangent is going to be your y over your x. Okay, the y value, negative 3, over, no, y value, sorry. The y value is negative 5, the x value is negative 3, so that's going to just be negative 5 over negative 3, which simplifies to positive 5 over 3. Okay, over here, cosecant theta, what's the radius over the y value? So the radius is square root of 34, and the y value is negative 5. So you can just bring that negative to the front. Okay, let's do secant theta. Secant is going to be the radius, which is the square root of 34, over the x value, which is negative 3. So I'm going to bring the negative out front. And then we have last, our cotangent is going to be your x value over the y value. Our x value is negative 3, y value is negative 5. Simplify it, 3/5. Once again, you can see the reciprocal functions also apply, especially here's the easiest one to see, just you have to be careful there. Alright, so in our next example, we want to find the sine, cosine, and tangent of all 4 quadrantal angles. Okay, so our quadrantal angles are 0 degrees, 90 degrees, 180 degrees, 270, with also their radian equivalent up there. Okay, and I have my definitions right here. So sine of theta is your y value over your r value, which in this case is our unit circle. So I just gave you an image up here so we can look at it. The sine of theta is going to be y over the radius. So what's the y value at 0? 0, good. And what's the radius of a unit circle? 1. So what's 0 divided by 1? Just 0. Okay, good. Now let's do the same thing for 90 degrees. When I come up here to 90 degrees, what is our y value? 1. Good. The y value is 1. And what is the radius of a unit circle? Always, yes, in this case, so that's just going to simplify to 1. Let's do the quadrantal 180 degrees. So we're now looking at this point right here. What is the y value? 0. What's the radius of a unit circle? Just 1, so you just get 0. Now let's look at 270 degrees, which is this ordered pair right here. So we're focusing on our quadrantal angles. Maybe this will be even better to highlight them. Okay, so now we're at 270 here. The y value is going to be negative 1 over the radius is 1. So this value is just negative 1. Alright, we're going to do the same thing with cosine. The cosine definition is going to be x value over the radius. Alright, let's start with 0, 0. What's the x value? 1. What's the radius? 1, so 1 divided by 1 is just 1. Okay, let's go to 90 degrees. So we're looking at this one. What's the x value? 0. The radius is 1, so what's 0 divided by 1? 0. Good. Moving along. Now we're here. What's the x value? Negative 1 divided by 1 is negative 1. Good. Moving on. 270. What's the x value? 0 divided by the radius of 1 is just 0. Good. Alright, now let's do tangent. Tangent is going to be your y value divided by your x. So it's this one divided by this one. So what's the y value? 0 divided by 1? 0. Good. Now let's move to 90 degrees. What's the y divided by the x? Undefined. Good, because you get division by 0. Undefined, and that's because the y value divided by the x value is this in this particular case, which gives us undefined. Alright, let's move to 180, which is the y value. 0 divided by negative 1 is 0. And what about at 270? Negative 1 divided by 0, which would give us undefined again. Good. So basically we moved around the unit circle using our definitions up here for the specific quadrantal angles only.